Hello and welcome to another video. In this video we're going to be working on minimum number of changes to make binary string beautiful. And in this one you're given a 0 index binary string of an even length, and a string is beautiful if you can partition it into one or more substrings that each substring is even and it only contains ones or zeros, and you can change any characters you want and you want to return the minimum number of changes. So here one of the solutions you can have is they show you here 1100, and that would take 2 changes. And then here you just need to change one of these, so that would be 1 change. And then here it's already like this is already fine. So there's kind of 2 observations you need to make to figure this out, and they're not that easy, but once you figure it out, the actual code and like everything else is super easy. So the first observation is for even length substrings, adjacent characters have to be in the same string. And when I say that adjacent, I mean like the first character and the second character, right? So like if it's like the index is going to be like even odd, even odd, even odd, and so on. Each one of these even odd pairs has to be in the same string, right? So like these two have to be in the same string. Let's actually make it a little bit easier to explain. So the way to better explain that is, so maybe not this adjacent thing, but here. So if I traverse this string 2 characters at a time, every 2 characters have to be in the same string. So what I mean is, like, we start here. So these 2 characters have to be in the same string. These 2 have to be in the same. These 2, these 2, these 2, these 2. Because no matter how I split it up, I have to split it up into either a multiple of 2 or 4 or 6 or something. And there's no way to split it up to have like these 2 not be in the same string, right? Like if I split it up like this, yeah. So if I split it up like this, these would be in the same string. If I split it up like this, and so on. So basically these 2, like if I go 2 characters at a time, the 2 characters that I get to have to be in the same string. And then the second observation is the easiest way to do this is substrings of 2. And that's because there's never going to be a case where you make a substring bigger than 2 and that's going to give you a better solution. So for example, let's say my substring is like 1111 or something, and I don't have to change anything here. Well, I also don't have to change anything in this. Let's say my substring is 0000, same thing, right? I never have to change anything in this. Now let's say my substring is this. So if I want to have it like this, I have to change 2 characters, right? But if I want to have it, but if I split it up into substrings of 2 characters, I also have to change 2 characters. So basically we can just dumb down this problem into, let's get a bunch of substrings of 2 characters and let's make sure those are equal. And so that's pretty simple, right? Like a substring of 2 characters is either this, which is no changes, this, no changes, or this, 1 change. And so that's actually all we have to do, is we can just break this down into substrings of 2 characters, knowing that it's never going to be better to have longer substrings, because longer will only mean worse or the same, right? So for example, if we have like, I guess if we have like this, actually, now that I'm thinking about it, longer might still be the same. Yeah. No, actually, no, I think it depends. Yeah, because longer might not necessarily be, because like imagine we have something like 0 1 0 1, and then we have like 1 0, and then we have like 0 0 something. You can't just be like, let me take, like, in order to make all this the same, you can make a couple changes, right? So you would basically take all the 1s and turn them into 0s in this case. But actually, let's do this instead. This will be correct. Okay. Yeah. So here, if we wanted to do this, we'd have to make 4 changes. But if we break it down to substrings of 2, this is 1 change, this is 1 change, this is 0 changes. So the bigger substring might be worse, like this example here, this will be 4 changes, but the smaller ones will never be worse, and they might be better. So essentially all we have to do is just go through the string 2 characters at a time, check if they're the same. If they are, don't add to the result. If they aren't, just add 1 to the result, because to make this into the same thing, you just need to change 1 of them. And that's basically it. So hopefully this kind of makes sense that like these pairs that I've shown always have to be in the same string no matter how you break it down, right? And also substrings of 2 will give you either the best answer or, yeah, they'll either give you the best answer or be tied with bigger substrings, but using bigger substrings will never be better, because if, like you really use example, right? If a bigger substring is all the same, or if I need to change a bigger substring into something, right? If I want to change this all to be the same, well, that number of changes can't be less than doing it this way. Because if I break it down like this, and I make all of these the same, I would still make those exact changes. Like if all of these substrings are the same, I'd still make all the exact changes. But some of these substrings might already not need changes, like this and this and this. So that's basically all we need to do. So let's code that. So we'll just say, and then we need to go through the substring. So and we can have a go up by 2. So we can just say if s char at I does not equal I plus 1, then we add to the result, we just add 1. And that's it. And then we just return result. But yeah, this is definitely not super intuitive. But some other things to notice is, like, if you try to go, let's say, the DP route, look at the constraints and know that, like, okay, I can't have that much in my state. I can have maybe like the index and then the last character, 0 or 1, that's fine. But if I have the index and like the length of the string that I used or something, that would be unsquared and that wouldn't work. So yeah, I don't think you could do a DP. Maybe you can, but just kind of some things. If the constraints were a lot smaller, then it would be kind of an easy way to figure out DP, because you can like figure out like, okay, what's my string length, what's my character I'm using, and so on. And then that would give you like an unsquared. So if this was like 1,000 or something, then it would be fine. But yeah. And then we should be able to run this. Okay, so pretty simple, at least code-wise, once you figure out these little tricks. Tricks aren't super easy because it's like a greedy solution. So this is linear and 1. So hopefully this was helpful. If it was, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.